the beginning, it was a dream destined to make a difference. An obsession for quality, performance, and innovation, driven by people with a real passion for perfection. Day in and day out, it's a commitment to hard work and a resolution to never rest on our laurels. Bow to stern, it's old world craftsmanship, layered in 21st century advancements. From the first draft to the final design, this is the legacy coursing through every Ranger boat. Hand-built, one at a time, it's a legendary level of leadership, dominated by determination and driven to deliver the ultimate ownership experience.
First, let me thank you for joining me today and taking a little bit of your time for me to explain to you what we're so passionate about here at Ranger Boats. We started in this business many, many years ago, and our philosophy is founded on some basic principles that Forrest Wood instilled in the company and in us, frankly, many years ago. We have developed that into what we call our 5-star advantage. One being quality. Quality is an all-encompassing term. It can mean a lot of things, but we look at it as from stem to stern, top to bottom, whether it's the product or the service or whatever we're involved in, we want it to be the best that we can make it. We talk about performance when we think about the 5-star advantage, and performance is much more than just what we might typically think of as the top-end speed of a boat. It is every attribute of the boat. It's talking about handling, fishability, all the things that come together to make that boat and blend together to make a total performing, high quality, very specialized fishing machine. Another aspect of our 5-star advantage is safety, and it's a very important part of what we do. I'm standing by a cutaway boat that has large pieces cut away. You might find it interesting to know that over 40 years ago, we got the idea from the U.S. Coast Guard when they commissioned us to build some cutaway boats for them. They were using them for educational purposes. We found it to be very effective, so we use them for educational purposes also, and to show people what we do inside, beneath the surface, so to speak, where you really can't see what's going on, perhaps in the showroom. But we use this to reinforce your peace of mind. As you look inside our boats, the deeper you look, the better we think we look. And so that's very important to us. Another part of the 5-star advantage is resale value. And what we mean by resale value when we talk about it is that we work real hard to build a boat that not only is pleasing to you in the showroom or at your point of purchase, but also years later, so that the durability is there, so that we've exceeded your expectation. And when it comes time for you to sell that and perhaps trade it for another Ranger, that your boat is easier to sell. And we find that to be true because year after year, we find that the demand for used Rangers is much higher than the rest of the pack. And the reason that is because Ranger is not only an iconic brand, but it's desirable because customers have come to know and expect that the Ranger will hold its value, that it's durable, that it will meet their expectations, even as a second owner. It was really one of the things that Forrest taught us many years ago, not only to build the boat the first time, but to build a boat, we believe we need to sell it 3 times. We sell it to the dealer at wholesale, we sell it to you, and then we believe it's also our responsibility to make sure we've built a product that is durable, that is long-lasting, that you can resell should that time come that you want to do so. The last part of the 5-star advantage is innovation, and we take that very seriously here at Ranger. It's been a part of our heritage. We've been innovative from the very beginning when this business was really starting to grow, and Forrest Wood was heavily involved in tournament fishing. I think innovation was so important that he saw the need to conserve, for example, and we started building aerated live wells. In fact, we patented those back in the very early 70s. So it's things like that that really drove us to listen to our customer. We have so many customers that fish professionally, semi-professionally, weekend fishermen, and they all have great ideas. And being able to sort through those and to understand and to separate the great ideas from the good ideas is very important. It's very necessary. And I'd have to attribute our ability to do that to the many people that we have here. Lots of our people have been here for several years. You combine that, a little bit of gray with a lot of youth, and that's what we've been able to do. We've been able to replenish people who are retiring from our company with good engineers and marketers and salespeople and just good craftsmen. And that's one of the things about our area that we've really been fortunate to be able to attract great people. At the end of the day, I think it really does boil down to having the people that have a real passion for what they do. And continuous improvement is a big part of what we do here. We don't rest on what was right yesterday. Good enough is not a word that we use here. We want to make sure that we're all continually driving improvement. And I think that all of that boils down to being able to deliver to our customer the ultimate ownership experience. I'm anxious to get into the plant to show you really what is inside these Ranger boats. And I think you'll be excited as we move through the plant and see all of the different aspects that go into the building of this great product. We're going to begin our tour today of the Ranger plant right in the heart of where everything begins, and that is what we call the gel coat process. It's where the paint is applied to the mold. It gets a little bit confusing when we're looking at the various components. So to begin with today, I would like to show you just a bit of the process, and I think it will help us gain an understanding as we go on through the plant to know what we're looking at when we're looking at some of these things in a bit of an unusual environment. So first of all, we build a master plug, and this is obviously a scale model of a hull. Once we get this built, it's generally out of wood. Sometimes it's cut with CNC with the finishing done by hand. Just depends on the model and the particular circumstance. But this will all be done. It'll be an exact replica, full size of the hull that we want to build. Once this is built, we cast a mold on top of this. We do that all here in Flippin, Arkansas in our engineering facility, but we'll cast that mold off of this plug. So we're looking at a master plug here, and then once we cast the mold, I'm going to switch from a hull to a deck just to show you for illustrative purposes, but this is a scale mold built on a deck master. This is the master, this part being the mold. And I'll just remove that much the same way we would pull that mold off of the master in real life, and we'll get a full-size mold, a deck mold in this case, and that will be highly polished to a very high gloss level, and then we will be ready to start the manufacturing process, which again, that's where we are today in the gel coat area. So we're going to start laying the gel coat inside this mold. It's a little bit different process that you would think of in an automobile, for example, where you would build the automobile and then paint it. We're going to paint the boat before we build it. So just understand that we're going to be painting this mold. In order to do that, because of all the various stripes and gel coat color changes that we have to mask that off into the mold. When we put the masking tape in, and they always do that by hand, we will lay the tape in to the standard, then it will be ready to push down the line into the first gel coat booth. There's a series of booths that we will add color as they progress down the production line. You've seen from the way that the material is applied, it's done by hand with a person using a spray gun, not a robot. That's because there are so many different colors and variations of a Ranger boat, and customization is a very high level. So what's happening behind the scenes is a lot of material testing going on. We are in a controlled environment where we control the temperature and the humidity very closely in this operation in order to optimize the performance of the gel coat on your boat. I think one of the big differences in what we have here is that, for example, the man that runs this department has done it for 36 years. He has people with a real high level of skill, and they're real passionate about what they do. These boats are customized. There's many of them the same color, but there's a lot of them that are a little bit different as well. So we really want to build a Ranger to fit you as near as we can. And so when your boat goes down the line, your order is riding with that mold. So we really do build them one at a time. We've looked at the gel coat process or painting, and it's important to remember in review that we put on several layers. We put down the clear coat, then we put the polyflake coat, then we put a backup coat behind that to keep it from being transparent. In a lot of areas of the laminate, we'll also come back and put a barrier coat for further protection against the elements. When we leave the gel coating process and give that time to dry and to cure, then we go right into the laminating process. The laminating process really, it starts to take on the character of the legendary Ranger hull. And what we've got is several layers that we'll put on, beginning with a skin coat or a fairly light layer that's actually going to build a barrier between that beautiful gel coat finish and the rest of the laminate. As those laminates or layers are added, a layer at a time, we can see that we're building it up in certain areas more than we are at other places. One of the things that it's important to see that as we put a skin coat on, we're starting out with a layer of generally chopped strand mat. As we do that, we're adding layer after layer of laminate until we get the desired thickness. Once we get the base hull thickness the way we want it, then we'll start putting the components on. Some of the things that make up that hull thickness are products like woven roving, which simply means that we've got roving woven together in the directions that we desire them to be. We'll lay multiple layers of this depending on where it's located in the boat in as we laminate or as we put the chopped strand mat or chopped strand fiberglass in between that. One of the other important things that we do, and it's part of our hull zone tempering, and that is that we've got continuous strands, continuous roving here. So you can see all of the strength that will be in this longitudinal direction. What happens when this is saturated is that we end up with a very strong rod that you might equate to rebar that's commonly used in concrete. Where we're putting that is in the strake areas of the boat. And what happens is we do this when it's wet so that it takes on the form of that hull or that exact strake, putting all of the strength in the longitudinal direction because we don't need any in the transverse direction. We're building that in another way. So if you will, we're building or zone tempering this hull strategically along the strakes, underneath the stringers in various spots so they have maximum strength with a minimum amount of weight. Another thing that's real important that we consider when we look at this is that this material has a very high glass content, which means that it's going to be extremely strong. Some of the alternatives that we know that are used in the industry is a putty that's used to fill those strakes on the bottom of the hull. And you can see that as we look at this material, it's extremely strong. I can barely flex it. But some of the putty, it's just there for filler. You can see that it's going to readily break into pieces. And that's the same with, there's various kinds and materials that are used, but they all have about the same result, that they will break very easily. Some will flex before they break, but none have the characteristics that this material has. Lastly, and very importantly, I believe, is several years ago, we developed and invented a pultruded fiberglass transom that's been used exclusively in Ranger boats now for many, many years. I want to show you why that's important. We're building this kind of a unitized construction. We have a pultrusion department, our own machinery that we built and developed here specifically for this material. And we build these materials and glue them together with methacrylate. They're built off-site up at the other department, and then they're delivered down to the hull laminating area where we're going to put this into the hull. This pultrusion material, the best way to explain it is if you're familiar with perhaps extrusion, where you're extruding aluminum, where they push a molten metal through a die, and out the backside is an extrusion or a form with a constant cross section. We're doing the same thing with fiberglass, only this is wet when we put it in, so we have to pull it through, hence the name pultrusion. So we have a machine that's literally pulling this through a die. You can see the thickness of this. This is a fairly typical piece that will have multiple layers installed in the transom, but look at the layer after layer that is in this. So there's a lot of engineering goes into this. We can put stress-directed fibers. If we want X amount of strength in the transverse direction, we can do that. If we need certain areas that, like this piece that I showed you earlier, needs to have a more strength in the longitudinal direction, we can certainly do that as well. So very important, it's unique to Ranger, something we're real proud of, and it's a very, very strong transom. Why is that important to you? Because as the engines have gotten bigger, 4-strokes have added a little bit of weight to the overall package. These pultruded transoms have been engineered to take care of that without adding a tremendous amount of mass into the back of the boat. On the bench, we looked at all the various components that are used in the Ranger hull. I'm up in a hull right now. This hull is still in the mold, obviously, and these components are going in. We have the stringers just tabbed in right now. We have the pultruded transom that we talked about earlier that's built as a component and delivered to the hull lamination area. That's glassed in before anything else goes into the hull, right after the laminate is complete. Then we put in the fiberglass stringers. They're all fiberglass. There's no wood or no other composite in the stringers, all glass. We do something that's very unique when we get to this area, and that is that we're just tabbing the stringers down to the hull, and now we're going to come back and, again, using those 0-90 or 45-45, whichever direction we need for the particular application. This is a 45-45. We're glassing those stringers down to the hull, all the way around the perimeter of the stringer. Then we're going to lay pultruded material. We even use it for our floors. And here's an example of the pultrusion. There's the stringer. What we'll do there is we glue this into place, these pultruded members. Again, lightweight, strong material that's fiberglass down solid. That gives us that one-piece feel. It gives us the real quietness that you have come to expect and know that a Ranger offers. And really one of the important factors of that is what we do to the stringers while they're still in the mold. We're going to foam fill all of these cavities that are open except for the center. And what that's going to do is we're going to pack foam into all those open areas. The foam is about a 2.5 pound per cubic foot of density. It adds a lot of strength, it adds a lot of insulation, and it adds a lot of quietness to the hull. And that's really what you get into when we're talking about the one-piece feel or the zone-tempered feel of the Ranger hull. It's all these components are working together. These foam tanks in this area are completely filled with foam. You saw that earlier in the cutaway, how we'd cut large sections away so you could really see the magnitude of the foam that is injected into these areas. It also adds a tremendous amount of strength to the back because these foam tanks are fiberglass to the hull, to the floor, and also to the stringers or to the transom. Really, all these components working together deliver a hull that is zone tempered. It gives that one-piece feel. It allows us to actually put an outboard motor on this transom. Just as we see this hull finished, pulled out of the mold, we could put a 250 horse motor on this, run it down the lake without any other structure. It's that strong. I think we've went over all the various components that go into the making of a legendary Ranger hull. The fiberglass pultruded transom, pultruded floors, all fiberglass stringers, the way they're lapped into place or fiberglassed into the hull, the foam system and how it's used to complement the strength, deaden the sound, give you that one-piece feel that you expect from your Ranger boat. What we're going to do now, we're almost ready to pull this from the mold, and I think you're going to see it pretty impressive as you see a new Ranger born when we pop it out of the mold. We've moved out of the gel coat. We went through the hull lamination process. Now we're over on the deck side where the upper half of the boat is actually laminated. The process is that we start through on top of the gel coat, putting a skin coat, we call it. That builds a barrier between the gel coat and eventually what will become the mass of the laminate. We have a term we call zone tempering. That really starts to take form here because not all areas of the deck need to be built the same. When we say zone tempering, we're talking about building different areas to a different specification because there are going to be different requirements, different stresses on it eventually when the boat is in use. We've used finite element analysis to confirm what real-world testing has already revealed to us, and it gives us an idea of where these stresses are under certain loads. In doing that, we're able to put the exact amount of fiberglass, the right kind of laminate, in the right direction, in the right areas. And as the deck goes through this process, we're starting adding layer upon layer until we get the general laminate where we want it. Then we'll move over and start putting stiffeners in. As you see on this one, some pultrusion has already been added, and that is going to be deeply embedded into the laminate in areas such as the seat base and places like that. This boat's moving down the line now where it's going to get more laminate applied. We'll look at it in just a moment. You see a lot of things that have been added on as this deck has gone through the lamination process. We started out with that skin coat to build the barrier, and we strategically placed different materials to bear the loads that we know that will be applied to this boat eventually. So whether it's a live well or a closed cavity bag molding, it's used for a storage or a rod storage liner, so many other components that are being built up in the other part of the plant as this deck is coming through the line. It's delivered just in time and fiberglass to the deck while it's coming through this serpentine production circle. Why that's important is that in this upside down position, it gives us an excellent opportunity to fiberglass all the way around the perimeter of those boxes. And what that does is ensure the dryness of them and eventually satisfaction to the customer. One of the things that we really pay a lot of attention to is that we want to make sure that anywhere a screw or a bolt or a piece of hardware is bolted onto the deck eventually, we want to make sure that that has the proper backing so that it will stay in place. And we use our pultrusion process to build a lot of the backup that we see in various places on the boat. You saw on the pultrusion and how it was really invented for the transom. We use it here, and perhaps for a different reason. I'd like to show you really what that means when you have that kind of backing on the back side of the deck. We looked at a lot of these parts, pultruded pieces on the deck that we just saw being laminated, but I wanted to show you in a little more detail. This material, as we explained, was developed for transoms over on the hull side. This material is unique to Ranger. It's built in-house, and it's a material that's pound for pound is stronger than steel. One of the attributes of it is it has a real high glass content, very little resin. When you get high glass and low resin content, you have a strong laminate and you have one that's very lightweight. We use this for backing of screws, trolling motors, cleats, and so forth. And I think I can show you in a little illustration really why that's good in the finished product and what that means to a Ranger boat. There's several different materials, and we're not picking on any one. The one that has the best screw retention, I believe, is this one. So we're going to take the best of the best, and we're going to compare it to pultrusion. Screw retention is important because we want it to hold. When you're out in the elements and your cleat is screwed through from the top, or the handles or the hinges on the lids or whatever, it's important that they stay in place and not back out or not strip. I'm going to screw this little handle onto this piece of material that's typically used for backup. Take a stainless steel screw, and we'll put a couple of screws in it, see if we can get it to, I'll be real careful not to strip them. I'm going to go down easy, but get it tight. And there we go. Put another screw in. And we'll put a third one in just to make sure that we're getting everything we need, everything possible. We've welded up this little handle, and you can see that that went into that material that's almost the same thickness as the pultrusion material that we typically use. So you can see with a little bit of leverage on this screw, it pops right off. It did, I guess, all it was expected to do, but the end result is not adequate. Now let me take this same material and we'll back these screws out of the hole. And I'm going to have to drill a pilot hole in the pultrusion material because it's so dense that you can't drive a screw through it without doing that. So I'm going to drill a couple of pilot holes. We'll get one here, and you can see the fiberglass dust. Let's see if we can line it up and get another one. Now screw our part down onto that. I'll need to be more careful with this because I can actually snap that screw in two. Okay, so I've got a couple screws. I'm not going to put 3 in this because there's absolutely no need of it. And as you can see, no matter how hard you try, you can't pull that screw out. The reason we do all this and the reason I want to show you is because we want you to have the confidence that what's below the surface, what you can't see necessarily in the showroom, is just as important. There's been just as much or more attention to detail given to that component as there has the surface that you're accustomed to seeing in a shiny, glossy finish. You've seen the laminating process and hopefully have an understanding of how we built the deck and got it to this point. But this is a real interesting operation because we're actually removing this deck out of its mold. Remember the small scale model that we looked at and saw how the mold is upside down and then a boat is being built in that position? Well, here we're raising it up out of its mold where it was laminated, and this apparatus is to stiffen the entire deck so that we don't put any undue stresses on that deck until we can get it turned over and eventually lowered onto its hull that it will be mated with. When the deck or big part is removed from the mold, we move it into this area of where we do the cutting. The cutting machine we're looking at is something that we developed a few years ago from our experience with actually cutting the pultruded material, which was very, very difficult to maintain equipment when you're cutting something that tough. We took it a step further here and we have a 7-axis robot that uses water to cut the fiberglass. When we move this deck into position and jig it up within a very close tolerance, then the machine is going around and doing its search now, looking for the accessory pack, the group, the standard equipment, actually going through a dry run of what it's going to be cutting. This system cuts with a very fine stream of water. It's a very small orifice at the machine head, but it's very effective, and it will cut fiberglass up to, well, very thick, and even without abrasive. We're just using straight water in this application, compressed to over 50,000 PSI. It's a very effective way to cut fiberglass, and it's unique to the Ranger plant. You've seen the hull built. We've built a deck. The two have been removed from the molds. Now they're going to come together. We've got a few operations to do on this deck before we ultimately raise it up and lower it down on top of its hull. They're lowering this apparatus in. We'll use the seat base holes, a pancake air cylinder. We'll expand that. Now we can lift the deck up. When the deck goes up in the up position, we're going to turn it over. Once we get it turned over, we can do some foaming in some areas where we can't otherwise get to. So there'll be some foam added, and then down the line we'll see another operation where even more foam is added so that we're virtually filling all of the available cavities. You'll notice on the deck that there's already been plumbing hoses in place. There are chases and tubing for the various things that go through the wiring in the boat or the electrical cables and so forth. He's adding a couple of more chases for wiring, and that will be foamed into place. Once that foam dries, then we'll reverse the deck back to an upright position and lower it down on the hull. The final operations on this deck have been completed. You'll notice that we've applied a putty material or bonding putty. The pultruded floor that I showed you a little bit ago is going to be bonded to the cockpit sole of this interior or this liner. So we're raising the deck up now. We'll flip it over one last time, put the hull underneath it. They'll start lowering the deck down into place. It's a shoebox fit, so meaning that it's going to lap over the top of the hull slightly. But once that goes into place, they'll get the bow on and then lower the transom down into position. Give it a slight boost and it'll pop over the outside perimeter of the hull. The last part of this operation is that they're putting a rivet in place around the perimeter just to hold it in place until it dries. Then later, when we come back and put the rubber strip on, or the rub rail we call it, when we install that, it'll be installed with stainless steel screws. There'll also be some laminating done and foaming together, so it's going to take on that one-piece feel from here on out, and it's beginning with this operation where we glue the deck to the hull and make it one piece. We finished our part of the tour over on the laminating side, and now we've come into the finishing room. The finish department is where we start putting on a lot of the components that really individualize the boat, and it also, a lot of the components that we're putting on here or installing are made in other parts of our plant. For example, we do a lot of CNC work and cut out a lot of the plastic parts or the polyethylene pieces that you'll see. We'd start out here with electrical systems. Even the electrical systems, we have our own adjacent department where we're building the wiring harnesses on a customized basis just for your particular boat. So that harness will be made alongside the boat, and it will be tested offline before it's even put in the boat, and then of course again when it is put in the boat. But that's just an example of what we do here in the finishing department. We're putting the electrical system in, highly individualized, depending on the unit of electronics, the components that you want, whether it's the power anchors, the fish finding equipment, the trolling motor, batteries, numerous other accessories are installed here in this department. We'll put the aerator systems in. You saw us put the live wells on the boats back in the laminating department. Well, here's where those components will come together. In addition to the electrical, we're building the plumbing systems offline where they'll be installed in the boat and tested. We move the boat up the line, we put the lids and the hatches. We showed you where the pultrusion is. Well, now it becomes important because when we're screwing these lids onto the boat, we want to make sure that we got that backup and that durability that we're engineering and fabricating and building in as we go down the line. We get to the end of this particular line where we install our engines. The engines are in an adjacent warehouse delivered out to an individual work order. We have a wide array and offering of engines. All of the major brands are put on here from smallest to largest horsepower, 2 to 4 stroke. We like for you to have what you want and let you decide what you want on it. It really individualizes a boat, and we offer a lot of components for that very reason. We have a lot of standard equipment, but we also offer a wide variety of factory installed options as well. We'll move up the line, get past what we've just talked about, be able to see a lot of what's going on, how it's come together, see a final test or two, and then we'll be able to see the boat actually go out the door. Our tour is getting near the end of the production line. We're doing a lot of testing. We'll put the boat into pool, go through a gamut of tests. Once that is cleared to that QC testing, then we'll lower it back down, put it on the dolly, move it to the very last station. Final components are put in there, including the upholstery. The seats, you'll notice, aren't in this boat yet. I'd like to run up to the upholstery plant and go through that in detail so you'll get a good feel of what really goes into the upholstery process in a Ranger boat. Inside the upholstery plant, you can start to see all of the seat designs come together. And it really is an integral part of your Ranger boat. The seat materials are marine vinyls, and we design each one here. We do molded foam so we can maximize the style and shape and comfort of each seat. We also use lightweight components and absolutely no wood so that we can ensure the durability of the product over time. In fact, integral to every design that we do here is the fact that we want to be able to offer aftermarket service in future years so you can service your product. So that's important to us. It's part of our 5-star advantage. And another way that we help you ensure that we keep the resale value of your Ranger at the highest level possible. Our upholstery fits our product exactly. It's built and engineered by the same people at the same place to make sure that you get the overall quality experience with the product. In addition to the upholstery plant that we've just looked at, I'd like for you to look at the closed cavity bag molding operation that we're pretty proud of. That's a department where we build all of the hatches, the lids, virtually all of the live wells and storage boxes. I think you'll find it pretty interesting as well. During the tour, we've mentioned several times the closed cavity bag molding, or CCBM process, that we use to manufacture a lot of smaller parts. Our consoles, our fenders for the trailers are built using this process. as well as all of the hatch covers, lids, live wells, and storage boxes. The advantages of CCBM are many, one of which is it allows us to mold and strategically place the fiberglass exactly like we want it for that specific part. You can understand that a trailer fender perhaps would have a different laminate schedule than a live well would. So we're able to do this because we're doing it over or inside a mold, and then we just add a silicone bag, pull a vacuum on this. We can control the resin and glass ratio very precisely using this process. Let me show you a little bit about a couple of things that really give us an advantage. One of the advantages in the CCBM method is that we can use a continuous strand mat, which means that we can make a lightweight and very strong material because it doesn't have any cut ends. It goes continuously through this laminate schedule. Another thing, we have a core that gives a heat barrier if it's over a live well lid or a cooler lid. We have a foam core, very rigid urethane core, and then we're able to add into the mold such things as this aluminum strip that we put in, which will be the backing for the lid side of the hinge. Another very important part, and we've talked about the pultrusion process and how we've integrated that pultrusion throughout the Ranger manufacturing process. This piece of pultrusion is strategically located in this lid core, and what it does, it ties the sides together. This is probably going to be an area where there's a lid shock. It's going to tie the surface to the bottom, make that very durable, and we already showed you the screw retention ability of the pultrusion, so we don't have to worry about the screws pulling out on the various hardware that we're using on these lids. The process is almost completed. One of the things we're going to do is shrink wrap your boat before we deliver it. We'll make sure all the components are in place, and then it moves at the end where we will lower it down on a Ranger Trail trailer that's incidentally been built at the same time to match. I'm real excited to take you up to the Ranger Trail trailer plant to show you one more place where we have really put a lot of attention to detail to make sure you can get to where you want to go fishing. We're inside the Ranger Trail factory right here on the campus where we build the boats. We started building Ranger Trail trailers many years ago as a result of not being able to really get what we wanted by outsourcing. Over the years, Ranger Trails have really evolved along with the boat. It's a very important part of your investment. Obviously, you can't get to the lake without the trailer. The fit is very important. We felt who better to ensure that that fit and everything is right and balanced to the boat than the people who build the boat. So that's how we got into Ranger Trail a long time ago. There's a couple of ways to build a trailer or materials to build it from. One is a tubing trailer, and tubing generally looks nice. It's strong enough if you pick the right tubing. The problem that we found with tubing is it has an interior, and in that interior it's impossible to paint or protect it from the environment. So it begins to rust over time, and actually fairly quickly. We chose to build out of channel, and we do that for a number of reasons, but structurally it's a great product to build the trailer out of, but it also allows us to put our road armor polyurea paint system all around it. So there is no inside to this C-channel. So you'll find that the basic frames of all of the Ranger Trails, all of the cross members are the C-channel so that we can corrosion protect it. When it comes to the axle, we use a hot dip galvanized material that's protected inside and out. And we do that because we use a torsion system. This member, center member, is connected to the spindle, and these outer members are rubber, and that's where we actually get the suspension. And it's an independent suspension from side to side. Unlike a solid spring or a solid axle that has a spring on each end, where if you hit something on one side of the trailer, a chuck hole, it will be transferred to the other end. These are totally independent. We also use LED lighting, which is the most durable form of lighting that is available for our trailers. Even in the backup lights, everything is LED. It's connected with a wiring system that we build in-house. We do that because we want the right connectors. We don't use connectors that are quick and easy. They're not allowed in our plant. What we're doing is we're putting a heat shrink method so that they're all plug and play, so that they're easily serviceable and as durable as the lights that they're connecting. In addition to that, we weld in a conduit or a chase for all the wiring to be ran through so that it's protected from the elements as well. Our Ranger Trail braking systems are aluminum, they're disc brakes, and they're on every wheel that touches the ground. On the tandem axle, for example, all 4 wheels will have disc. Gives you that optimum stopping ability. Another great option that we offer on the Ranger Trail that we developed recently is the parking brake system, which mechanically locks down the back disc brakes. What that does is when it's applied, we're able to lock the brakes, and then we can also lock it into place. So you can see the advantages of that. If you're sitting on an incline or you're behind the hotel and you're worried about someone trying to pull your trailer off, by locking this, it makes it almost impossible for it to be moved without detection. Another feature on all Ranger Trail trailers is a center point tongue jack. What this does is folds up very neatly on the center line so it stows away out of sight. Its location on the center line makes it much easier to move the trailer around when it's detached from the vehicle. Another feature on the Ranger Trail trailer is this swing away tongue. You can pull the pin, swing the tongue to the side. It does a couple of things. Number one, you can lock it in place so it's a theft prevention measure, and also it allows you more room, especially in the garage and tight quarters. We also build the fenders in-house, and they're color coordinated to match the particular boat that you're ordering. They also have integrated bunks. They're corrosion resistant, custom fit, and built specifically for the trailer that we're putting them on. To illustrate the durability of the polyurea system that is standard on every Ranger Trail trailer frame, we've developed what we call a gravelometer. It's just a little machine that's blowing air and pea gravel, typical of what would be on the highway. We're putting that in the hopper. We're introducing it through forced air. And I want to show you, this is kind of the standard 2-part polyurethane system, a real good durable finish. Let me clamp that into the machine, put a few gravels to it, and let's see what happens. Clamp this in, turn the air on, introduce a few gravels out of the hopper into the airstream. Let it run a few seconds just to make sure that we're getting the gravel flow, and we are. We'll remove this one from the machine, and as you can see, the gravel has wreaked havoc on that finish all the way to the metal. Let's do one last one. And this actually has a 2-part urethane and the road armor on 1/2 of it. We'll test it side by side in the machine. We'll remove this one. You can see what the results are. This being the polyurea side, and this is the painted side. This is all the way to the metal. The only thing we have on the surface of the polyurea is a little bit of dust, which will just be easily removed. There's absolutely no damage to the surface at all. I want to thank you for taking the time you have today to go through the plant tour, to let me talk and tell you a little bit more about Ranger than perhaps you knew before. We don't take lightly the fact that you're interested in our product or that you're an owner. We want to make sure that you understand how our product's built, but more importantly, get an opportunity to get to know you better. To the many Ranger customers that are out there, we want to thank you on behalf of all of our employees and associates, our dealer organization. We thank you for your business. If you are not currently a Ranger owner and are interested, we'd like to invite you into the Ranger family, and it is a family. There's a lot of pride of ownership. We welcome you and ask you if you have any questions or about what we've talked about today or anything we didn't cover. There's a number of ways to get in touch with us. We'll put those on the screen, whether it's by email or phone, but you'll get a chance to talk to real people and answer your questions, and we look forward to working with you in the future. We thank you very much, and good day.
With so many patents, trademarks, and industry firsts, coupled with an imposing record of research and unmatched experience on America's toughest tournament trails, Ranger continues to set the pace. creating, developing, and pushing innovative technology to deliver the highest quality, strongest performing boats on the water. It's a focus that's hard to miss, and you'll see it in the many faces of the Ranger family, whether it's during the making of each custom design, while it's traveling down the road, or as part of so many special times on the water. It's a confident peace of mind that consistently reinforces our commitment to the most rewarding levels of customer satisfaction. Ultimately, it's a tradition of extraordinary craftsmanship, born of a dream and driven by a passion for perfection. This is the hard-earned legacy of Ranger, created to excite, engineered to excel, and built to be yours.